All right, so one thing that I have to make note of is this is due Saturday night, is that right?
Yeah.
All right. Starting almost, well, soon after class, maybe I'll have a little bandwidth late tonight, but I'm going off the grid. I've had it with civilization. No, I'm going to some camping activity where cell reception is poor. So, in class right now is really your best last time for me to help you. I have noticed a little bit of some students stepping in Piazza and offering up answers and suggestions, and I'm immensely grateful for that. And if you've got, I would be very grateful if you all would, for those who feel like they have the project well in hand, or at least have something they feel they have to offer, if you would be aggressive about paying attention to what's happening on Piazza, excuse me, and help your fellow classmates get through the project in my absence. I would definitely like that. I kind of groove on that kind of thing anyway, but in particular, since I'm not going to be available, if you all are able to help each other, that would be good. Even if some of you want to create like a coding session, right? Post on Piazza, hey, anyone want to spend your Friday late afternoon in the 4th floor of the library, blah, blah, blah. So definitely help each other out in getting this done. All right. So with that as preamble, is there anything that I can kind of go over additionally or that I haven't gone over to help clarify some confusion? Variables. Just in general?
Yeah.
All right. So I think the best way to come to an understanding about variables is to put them in the greater context of expressions. So we know that certainly syntactically the design has been structured such that we have this big expression hierarchy of classes and the various operators inherit off of this expression, and so does variable. And the idea is, so with this expression we have, what's the order of operations? We have 4 times x, we have 9 divided by y, then all we have left is addition, so that kind of goes left to right. So then after that we have 3 plus that, and then we have the result of that plus that. Right, so if I was to group this with parentheses, that would be the order of it. The key to one of these binary operators, and let me pull, let me mix this up a little bit. All right. There are 2 things that we can gather from this particular operator right here. Is one, it has a type, and the type is referring to what kind of thing is this after it does its magic. And we can certainly look at this and know that 9 divided by 3 is an integer. Likewise, if I was to throw in a point 0 here, we would know that the type of that operation after it does its magic is going to be a double. And then just to drive it home even more, what is the type of that expression after it does its magic? This portion of it, the division operator. What is the type of that? Int. Why is it int? It is an error, yes? It's nonsensical to divide a string into an integer. If there's an error in processing an operator, then the result is always a constant integer 0. So you don't look at 9 divided by FDSA and say there is no type. You say the type is an integer. All type checking needs to be done in GPL.y. It needs to be done at parse time. That is precisely the reason why we have this type member function for all of our various operators. And then, so what your binary operators are going to do is they're going to look at the type of the left-hand side, the type of the right-hand side, and then they're going to decide what the result of that is. If it's integer, integer, it's going to be integer. If it's integer double, it's going to be double. If it's integer string, it's going to be integer because you know it's going to be an integer, right? You can do a series of simple checks in that type function to return the proper type. All right. The other thing that occurs is evaluation, which is not the type of it, although that certainly is part of it, but the value. And of course, that value must be the same as what the type produces, the kind of thing. And how do you calculate the value of something? Just thinking of it in abstract terms, for anything in that expression hierarchy, there's some algorithm you run, and the result of that algorithm is always going to be a constant object. At this point in the game, it's going to be a constant integer, a constant double, or a constant string. Evaluate always. Doesn't matter what it is, it always runs some sort of algorithm that is a black box, and the output of that algorithm is going to be a constant, one of those, what is it, integer underscore constant? Is it the type first? Integer underscore constant, or double underscore constant, or string underscore constant. It's going to be a pointer to one of those three things that gets created by virtue of calling the evaluate function. That's what evaluate does, is it runs an algorithm in a black box and it gives you one of three kinds of objects. That is exactly true of variables. When I have this x sitting here unadorned, it has a type. That should be pretty straightforward, right? It's the kind of variable that it was when the variable was created. So that's straightforward. And it has an evaluate function. That evaluate function is going to run some sort of black box algorithm, and it's going to give us back a constant integer, constant double, or constant string. Now, the only question that remains is what is that black box algorithm? We're so familiar with math that it doesn't throw us for a loop when we imagine the algorithm here. There's some checking, for instance, to make sure you're not dividing by 0 during evaluate time. And then assuming that there are no issues like dividing by 0, then you just simply do the calculation. You take 9 and you divide it by whatever's on the right-hand side, and you create a constant object whose value is whatever that division is. The black box algorithm you do for a variable is slightly different. A variable has an expression pointer, or it does sometimes. And it also has a symbol pointer. Always. The symbol, and these are initialized at parse time, right? It is while you are parsing the program in GPL.y, it is this rule right here variable. And again, how does this rule get called? Well, you just have to this variable, come on, Todd. I'm sorry, let me use the proper terminology. This production is called in one of two cases: when the scanner scans and it sees TID, or it scans and it sees TID and a set of square braces with something in the middle of it. In the first case, TID, that's what this is. That's TID right there. If you open up GPL.L, you're going to see a regular expression. Well, hell, let's just look at it. TID. All right, here it is. An underscore or an uppercase letter or a lowercase letter followed by an underscore, 0 or more, underscores, uppercase letters, lowercase letters, and digits. All right, we learned this in 111. That's what a variable is. And what do you do when the scanner scans that and sees it? It creates a string for the semantic value. This is the semantic value. In my example, that would be X. So the semantic value YY text is going to have it's going to be a single string, a single character string, X. And then the token that gets returned that is associated with that semantic value is TID. That in turn is caught by the parser, and the parser then says, okay, this is part of the variable production. Well, what do you do when you come across X? Let's keep the semantic consistency here. What do you do when you come across something, a plus sign, and a something? You create a plus object. Actually, we went ahead and did the binary. Let me use multiply instead. When the parser comes across something, a multiplication symbol and something, we create an expression object, something in the expression hierarchy. We create something that we can ask what its type is, and we create something where we can ask it to evaluate itself and give us a constant back. Likewise, here we create some sort of expression object, something that we can ask it what its type is, something that we can ask it to evaluate. It'll run an algorithm and give us back a constant object. So just as we have created a class for handling the plus addition, we have a class that we've created to handle variables. We use the same class. I suppose in theory we could use two different classes. We could have variable and variable array, but we kind of munged them together. We just call it variable, and it handles both individual values like X, and then it also handles things like, maybe I'll do this, like Y sub 82. So that is what this is here. Now let's talk a little bit about when we ask variable to evaluate. Let's look at the very end game, the return statement. Whatever it does, whatever does whatever. The return statement for the variable, for a variable object that has been created. Here, let's look at X. We're going to create either an integer constant object, a double constant object, or a string constant object. The kind of thing we create depends on what kind of thing X is. Well, X is either an integer, or X is a double, or X is a string. Right? Somewhere prior to this expression, one of these lines of code was encountered. And what happens, what are lines 1, 2, and 3? Those, what would you call those? just general. You get some person says, what does double X mean? What is that? And you say it's a variable declaration. And when you parse a variable declaration, what do you create? You don't create a variable, you create a, let's look at variable declaration. What are we creating? Variable declaration. Ah, symbol. Exactly, you create a symbol. So when we encounter the variable here, we do a little paperwork. We start interrogating all our symbol crap, and we get back the symbol that we created somewhere in the past. And now we attach it to this variable object we're creating. That's what all this effort is here. So you have a little error checking because maybe I've created X, but I haven't created the variable XYZ. You get some sort of undeclared error, right? So what you do is you interrogate the table handler and you say, hey, give me X. And it'll either say, okay, here's the symbol X, or it'll say, I'm sorry, I don't have any such thing. If there's no such thing, you generate an error. Let's assume it finds that you get the symbol back. Now we take that symbol, sorry, I keep doing that, and you create a variable object from it. And what do you pass in? You pass in the matching symbol. So note over here, one of the two things that we always set is the symbol. Why is it important for my variable object to be attached to the symbol? Because somewhere down the road, I don't know when, somewhere down the road, someone's going to ask me to evaluate. Note on the right-hand side of the pane, when I'm looking at lines 498 through 504, I'm not evaluating anything. I'm setting things up. On the left-hand pane, line 4, there's a whole bunch of setup there and no evaluate. There's no evaluate to be seen when you process line 4. What you're doing is you're creating a whole bunch of classes in the expression hierarchy. You're creating a couple plus objects. I said classes, I meant objects. You're creating a couple plus objects. You're creating a multiply object, creating a divide object. You're creating a couple variable objects. We're create. We're also doing type to make sure we don't have any type mismatches like the 9 divided by FDSA. And then all these objects are linked together in that expression tree that we looked at before. And then they just sit there. At some point in the future, we're going to ask the very top of that tree to please evaluate, and it's all going to cascade down, and everything's going to ask everything to evaluate until we have a constant object at the end of it. Okay? So when we ask a variable to evaluate, we just talk to the symbol and say, hey, what's your value? And it'll say 82. And then I say, okay, I'll create a constant integer, and I will give that constant integer the value 82, and that's what I give back when I evaluate. So that's the purpose of variable. It is to give us a consistent behavior that we get when we do something like plus or multiply, which is to interrogate its type and to be able to evaluate when the time comes. The only thing that is a little bit confusing is on the right pane, line 505, that rule that is dealing with arrays. Okay? And when I say that everything in the expression hierarchy, when you ask it to evaluate, is going to return a constant integer, a constant string, or a constant double, people get a little freaked out because they're saying, no, line 505, that's an array, that's not an integer, that's like an array of integers or something like that. And then my retort is to focus you on the left pane, on line 4. Let me get my caret and move it. That right there is not an array. That is going to be a double or an integer or a string. The 83rd item, counting starts at 0, the 83rd item in the array of y is going to be an integer, a double, or a string. Right? We don't look at arrays, we look at elements of arrays. That's what we're evaluating. And so that gets us to line 8 on the left-hand pane, which is sometimes our variable has a pointer to an expression, and that expression is whatever's in the square braces there. So when the variable is asked to evaluate, the variable in turn asks whatever was in the square braces to evaluate. It may be hard to visualize that when I have 82 here, but let me do this. WW times Z plus 6. Now, when the time comes and the variable is asked to evaluate, it will ask what's inside there to evaluate, which is a neat little mini expression tree. And it'll come back with a constant object. When it comes back with a constant object, we just simply ask that object, well, give me yourself as an integer. And it says 82. And now I look at the 83rd item in that symbol. And that's what I end up creating and returning as a result of evaluating that variable. All right. Did I clarify or confuse? Or neither? That was so Tuesday, and you've got Thursday problems you're dealing with. Other questions? Yes?
Test 144.
Test 144.
Mainly the last 3 lines, and where it's affected, something like that.
Okay, so your question, repeat the question again.
Where to check for lines 5, 6, and 7?
All type checking occurs in GPL.y. So, line 5 is a variable declaration, right? So I go to GPL.y, and I look for variable declaration, and it is going to be this rule here, the second rule. So shoot, let me quit this. Let me bring it up over here. All right. So casting my eyes back over to the right side, simple type. I'll look at line 5. Int d hello. So simple type is integer. TID is d, and then hello is the expression in square brackets. So what I need to do, in fact, the code is right here already. I create an index, and I default it to 1. And now what I'm going to do is I'm going to try taking, no, this isn't quite right. Yeah, I think this is right. For the declaration, you have to do this. So here, here I have to evaluate because I need to know at the point where I'm creating this symbol, right? I'm ultimately creating a symbol. I have to know how many of them I'm going to need. So I evaluate it, and I assume that it's going to give me an integer. So I say as int. But I know that, for instance, looking at line 5, if I ask a constant string to give me yourself as an integer, let's look at constant. I hate when I do that. So hello was created as a string constant. When I ask for that string as an integer, it's going to throw an exception. It's going to throw a string. So I put that in a try block, I catch it, and I throw the error, and I say the array size must be an integer. And then I go ahead and release it. So I don't need it anymore. It's bogus. It's bad. I can't use it. And then I have a switch on $1, which is my simple type. Let's look back over here. Here's my simple type. If it's an integer, there's where I create my array. And I feed it how large is my array, whatever is an index. Now, what is an index? I had an error. Well, I cleverly designed this code. Shit, I keep doing that. I cleverly designed this code so that when I created index, I gave it a default value of 1. Let's look at a use case where I don't have anything bad. So I say int xyz 100. I say $for evaluate. I ask for it as an integer. That gives me back 100. 100 is assigned to index, right? So when I go down to the switch, I'm creating 100 of those things. But if something went wrong, then what happens is I throw, as part of doing this, I throw an exception, and the assignment never occurs. So index is 1. So if something's gone wrong, index is 1. If something has gone right, then index is whatever that expression evaluates to. And of course, the switch statement's pretty shallow. Depending on what simple type is, it'll create an array of integers, an array of doubles, or an array of strings. And note that I do go to the trouble of initializing the arrays to those default values, 0, 0.0, or empty string.
Is that all the same for line 7, I think it was?
So 42.0 divided by 17 is a double. Yes, it is illegal to have a double as an index for the number of items that you want. And then we just kind of repeat and rinse as far as looking. We look at constant.h, and I look for the double constant, and if I ask a double constant to give me yourself as an integer, it's going to throw an exception. So coming back over here to this code, let me get rid of that. I try to get it as an integer. It's going to throw an exception. I generate this error, and instead it's going to say, hey, you tried to give me a double, which is what came into the exception. That's what was thrown. So yeah, it should handle everything. So I believe there are only 2 places in GPL.y where you evaluate. 2 rules, I think. You have to evaluate when you, in a variable declaration, you do have to evaluate at the time of the declaration to find out what this index is, so you know how large to make the array and the symbol. The other time when you evaluate is when you have some discrete variable is for the assignment, right? Your optional initializer gets evaluated? I think that's basically it. This project's a little bit peculiar because it feels like you're creating the entire structural underpinning to GPL. And the only thing you can do is create variables. That's it. Isn't that weird? And the reason that the whole thing works is that you can have arbitrarily complex expressions as the what you have between the square braces here, and you can have arbitrarily complex expressions for the optional initializer. That's what's letting this whole thing hang together. What we're missing is we're missing if statements and for statements and print statements. And what will happen with those, and we do those, I want to say it's the very next project, if not one of the next two projects. It'll end up being remarkably simple to add those statements because a while statement has a condition, right? So you'll have a class that you create for a while statement, and it will, what do you think its private data is? It's the expression that is the truth part of that. Well, when do you evaluate it? Well, when your code hits the while loop, you'll evaluate, and then, oh, there's one other expression. So there's an expression pointer to, here, let me just write the damn loop. While xyz times 3 times 4 divided by 9 plus a. And here you're going to do things like a equals 4 times abc divided by 2. And you're going to do other stuff. Yeah, let me add another one. xyz plus equals 36 plus 2. So a while loop has, if you think of it as a class, it has two pieces of private data. Now, when it comes time in your code to run this while loop, what you'll do is you'll say the truth condition evaluate. If that's true, then the loop body evaluate. The truth condition evaluate. If that's true, then the loop body evaluate. And the loop body is going to be a linked list of expression trees. It'll be this one, and then the next pointer is going to be this one. And so it'll just rifle through that linked list going evaluate, evaluate, evaluate. Now you go back up to the condition. Evaluate, check it for whether it's true, and then rifle through the linked list evaluating those. So that when we get to that stuff, that's how that works. It's just providing a little bit of a framework to kind of, basically, all these statements, the for loop, the while loop, the print statement, those are all basically, what I want to say, like a towel rack where you can hang these expression towels.
Is assignment an expression?
No. So in GPL, assignment is a statement. Yeah, so I guess this would be a statement as well, right? Or this would be a class. This would be a class, the assignment class. This would be a class as well. And they would each have expression pointers hanging off them. So these are all just coat racks where you're hanging the expression. That's what I want to say, coat rack. You're hanging the expression coats. That's all these statements end up being. What else you got for me?
Can you undo that real quick?
Redo this?
I mean, just undo that last delete. On line 10, by the time it gets to optional initializer, which expression's actually there? Is that whole thing sitting there, or is it the condensed version of that?
So by the time we get to optional initializer, let's look at GPL.L or .y. All right, so there we were. Let me go back to that. So when do we hit this rule in the parser? We don't hit this rule in the parser until we've hit this, until we've done this production, and this production. This is actually a terminal token, so there's no production per se. But we have to do, before we can do this rule, we have to complete the simple type production and the optional initializer production. Let's look at the simple type production. Here's the simple type production. It's basically got to be one of these tokens, the word int, the word double, or the word string. Okay, that one's easy. This production is either empty, nothing there, or it's an equal sign followed by an expression. Well, what's an expression? Now we traipse down and we hit where I want to go with this is, there's all our statements. Here's expression. Okay, so what is an expression? It's one of those. So your entire expression tree gets built before you end up at variable declaration. So this is our entire expression tree, which is basically just a pointer, right? It's a pointer to the top of the tree. It's a pointer to the plus, and the plus has a left and a right, and the left has an x times a y, and so there's a times, and that's got a variable on the left and a variable on the right, right? Just have this tree built out that I've done a couple times in past classes. And the very top of it is an expression pointer, just a pointer to the top of it. Well, how do you know that? Well, let's look up right there. Boom. The optional initializer is an expression pointer. That tree's been built. Test 104. I'm sorry, say it again. 103. Okay. What about it? Which two? It's B as in boy. B. Those two. Yeah. So if you're getting the rest of them right, it might very well be in order of. Oh, there are several of them wrong. It's going to be one of two. You're getting some of them right. All right. So the two places to check is you actually look for here. You make sure that this is right. You got to make sure you have that. All right. That's the first step. Make sure you didn't get those invariably switched or something like that. The next place is to search for %left and make sure that T or is a lower precedence than T and. Then And if you got the precedence right, then the next place to check is you have to crack open the evaluate code for OR and also for AND. And ensure that that code is correct. If you're looking at it and it looks correct, I have long, as a programmer tip, have long been suspicious of my staring at something and being convinced it's true. So what I would do is I would start putting debugging statements inside of the evaluate functions for OR and AND start doing examples, right? You want to do stuff like this. You want to say printf false or true. I'd run that and make sure it's giving me true, and then I'd reverse it. I'd say true, false. See that you still get true. You do all four, right? False, false, true, true. You make sure you're getting all the expected results, and then you do the exact same thing for AND. And the moment you get an unexpected result, then there's a place to try and track down a bug. Yes?
How do we know when to break out of an error or not?
So in the parser in gpl.y, I guess now that you pose the question to me, I'm struggling to come up with a generic answer that is sufficiently detailed to not be useless. If I have I don't want that. You have to have an understanding of the order that things are occurring. So if I look at this example variable declaration, when I am done, let me go into some code here. All right. So I say int x equal, let's look at a few examples. Int x 10, int y. Right. So in both lines 11 and 12, what is inside, we have to understand that what is inside the square braces is going to be evaluated first. And I guess the question to ask is, when you're done with line 11, what should be true no matter what? And when you're done with line 12 is I guess a better one to look at. When I'm done with line 13, what has to be different? Or let me ask it this way. Okay. think in terms of what you want to occur on 15. On line 15, does in and of itself, is there anything wrong with line 15? No, right? All right. When we get an error in our C++ programs, what the compiler does is it has to make some decisions, and it has to kind of try and patch things together so that it can do intelligent parsing, or I should say informative parsing further down in the program, right? You don't just get a missing semicolon and then the whole thing craps out and stops on you. It goes ahead and makes some assumption and it goes on to the next statement. So when problems happen with line 13, we still want y to be in the symbol table so that line 15 can be parsed. Okay? So now, using that kind of information, when I look at what is inside the square braces, that is definitely going to be an error. I don't want to break out on that error. I want to, and in most of these cases, well, not except for this one, in most cases, if you have an error, I guess, let me sidetrack a little bit. Int w equals 3. In most cases, if there's a problem, particularly with these operators, if there's a problem, you don't totally bail out. You fix the problem by giving a constant integer 0. So 3 plus FDSA actually works just fine. We get 3 FDSA as a string. The problem is when you try to then assign that string to w, w is of type integer, so that's where you get an error. You don't crap out and leave w undeclared. What you do is you turn 3 FDSA, you basically get rid of that, and you assign a constant integer 0 to w, and w ends up in the symbol table. Likewise, we have to make some corrective action on line 13. We don't bail out and not do anything else. We have to put some valid index in there for creating an array of integers in the symbol table. Despite everywhere else, we kind of make 0 the default. It doesn't make sense to make 0 the default here when you're creating an array because you need at least one item. So for arrays, you're going to have to take any errors and make that index a 1. And that's some code that we were looking at. I'm trying to think of... So I guess, how can I generalize? If I'm dealing with operators like a unary operator or a binary operator, I'm generally, if something goes wrong, I need to make sure that before I totally bail out, I am giving back a constant integer 0. For arrays, I have to make sure that I ultimately end up with an index of 1. For bad type mismatches, you end up creating a type that matches, which will be integer 0, I guess, for integer, and 0.0 for doubles. If I tried to assign, right, then 0.0 gets assigned to D, which actually works. You just use an integer 0 and it gets promoted to 0.0. So I don't know. I'm hemming and hawing a little bit because I'm having great difficulty coming up with a generalization. But I think the main focus is variable declaration. Make sure the variables get declared, except in one case. Let me give you... Line 13 it's going to generate an error for FDSA, but it will end up putting y in the symbol table, an array of size 1. When I hit line 15, that's a redeclaration error, and I don't create anything, right? So that's the kind of context you have to be aware of. And I hope, for the most part, that the various GPL tests are thorough enough and stepwise enough that it can help walk you through how you need to be handling each of those. But yeah, that's the bottom line, is that I have a hard time just painting the generic picture. It really depends on the context of each one. So there you go. That's my non-answer for you. Anyone else got a question that I'm not going to be able to answer very well? Huh? Personal questions. Problems at home? As far as individual, yeah, that's fine. Before I do that, are there any other group questions? All right, I'll end the recording on that low note of being unable to satisfactorily answer that last question. And see, the advantage I've got is I can just rewind the video and just cut it off right when I'm ending on a high. All right.